Good afternoon, my name is Jared Hayes and today I will be presenting a research paper, the role of ankle strength in lower body speed and power. Bigger, stronger, faster is an ever-growing motto in collision sports today, as coaches and clubs alike look to physically dominate their opposition. Speed and power are key attributes in all sports, particularly collision sports such as rugby league, union, AFL and gridiron. It has been shown that 5 and 20 metre running speeds improve with the use of low volume, high intensity dynamic strength exercises of the lower limbs. Takeoff speed, maximum jump height, workload and power are significantly higher where strength exercises are included in training protocols. And therefore, it is apparent that athletes who can run faster, accelerate quicker and jump higher have a distinct advantage over competitors, assuming they have the same skills and abilities. The squat is an essential pillar to all strength and conditioning protocols as it activates multiple joints and recruits total body muscle activation, with major joints being used in the hip, knee and ankle. The dynamic jump squat specifically is used to develop explosive power that is key during the acceleration phase of running and jumping. The aim of this research is to determine if there is a correlation between ankle strength and explosive power. Using the dynamic movements of a jump squat and ankle strength test, dorsal and plantar flexion, to explore the role of ankle during explosive movements such as a 20 metre sprint. This will determine the importance of ankle strength when implementing strength protocols for speed and power into the programs. Our hypothesis states that there will be a direct significant correlation between ankle strength and lower body speed and power, i.e. the jump squat and 20 metre sprint. The results will provide a basis for development of specific training programs that will allow athletes to attain optimal training and development. Within subject design was utilised to investigate the effect of ankle strength through the Biodex ankle strength test on lower body dynamic movements, the jump squat and speed 20 metre sprint test. The subjects included 7 males with a mean height of 176 centimetres, a mean weight of 89 kilos and an average age of 29 and a half. All participants were apparently healthy and volunteered to participate in this study. Subjects were informed as to the experimental procedures and signed informed consent statements and medical history forms in adherence with national ethics statements approved by Central Queensland University prior to any data collection. Tests were conducted over a 5-day period. They were included as activities of residential schools. All variables were tested were part of other research projects as well, which may or may not have an effect on the results. All the results were still considered valid as the results were part of baseline testing and sufficient recovery was provided. The results, we used a Pearson product moment correlation coefficient that was used to determine if correlation between ankle strength and dynamic lower body movements was apparent. 2 tests were run to determine the results between ankle and the jump squat, and then the ankle and the 20 metre sprint. The results showed a weak positive correlation in both tests. However, there was no significant correlation. They were considered to be quite weak, with a p-value of 0.476 for the jump squat and a p-value of 0.0848 in the trial with the ankle and the sprint speed. Here you can see in these tables that there is a very slight positive correlation. The results clearly show no significant correlation between ankle strength and the ability to perform dynamic jump or sprint 20 metres. This rejecting our hypothesis that there will be a direct significant correlation between ankle strength and lower body speed and power. Ankle strength has been proven to be important in stability and should still be developed in multi-directional sports. Although there was no direct correlation between lower body and explosive power, it is important that the ankle serves as a foundation of closed kinetic change during the squat. Mobility and or stability limitations of the joint could inhibit the effect of the squat. Fundamental changes in immobility and stability can independently affect performance of the squat. It is likely that improvement in joint mobility are key for improving the squat, a measure that was not considered during our research design. The ankle appears to play a multifunctional role of balance, stability, mobility, and strength. The role that the ankle strength plays in straight line speed and power has no significant correlation. Future studies that explore ankle range of motion, ankle strength, and lower limb speed and power may be beneficial. In light of the findings, it would be suggested that ankle strength is not relevant to straight line speed and power. However, it may be more relevant at increased loads and may be more specific to lateral speed. Coaches should focus on exercises that activate the whole lower extremities that require multiple joint activation, as well as mobility and range of motion within the lower extremities. Further investigation into the role of the ankle at increased loads and lateral movements are required. And this concludes my presentation today. Thank you for your time. Have a great day.